Hello and welcome to another episode of the Double Electronics. Today we're going to look at a 100 watt LED driver that I built up to power these nice little 100 watt LED chips for studio lighting, for just general room lighting and other things. There wasn't very much DC to DC 100 watt converters available on eBay at least. So I built my own circuit board, built the own schematic, and used a very special chip designed for running high power LEDs. This is the DC to DC converter on a little tiny board. So let's get started. Let's first start out with the schematic. This is the buck controller. It's a LM3409HV, meaning that it can go from 6 to 75 volts. So that's moderately high voltage for a buck controller. Here's the main current path for the LED. The current goes down here through the current shunt resistor, and then there's the current shunt sense lines right here, which measure the ramp of voltage going through them, which then turns on and off this MOSFET right here. It's a P-channel MOSFET, which is interesting. So then there's the recirculating diode right here, and an inductor, and then a smoothing capacitor, and then there goes the output to the LED. Over here is this selects the switching frequency on this MOSFET, and the enable pin, you just pull that high if you want to turn the whole thing on at max brightness, or you pull it low if you want to just shut it off. These two resistors right here, they set the under voltage lockout of the system. So if the voltage goes below these two set values, there's one set value, the whole device shuts off. That's good for like battery powered lithium ion circuits. In here is just a little header that I put in there, so you can make it easy to daisy chain these. Since I put the two connections right there just shorted together, you could just put a 4-pin connector between those two boards and just daisy chain. To turn it on, you jumper these two pins right there. You jumper those two pins right there. You turn it on, and to turn it off, you can jumper those two pins. That's just a really simple control of the device. This connection right here is so you can connect a potentiometer to it. It's really easy. 1, 2, 3. Automatically does the analog dimming on it. Just a very easy, simple way. I didn't do anything fancy with the PWM, but there is an option to put PWM through this enable pin over here. So the reason why I put 3 resistors in parallel is so you can set the current to different amounts. So just with the 0.08 ohm resistor, you can get 2.5 amps. If you add a 0.47 ohm resistor, then you get 3 amps through the LED. And then if you add another one, you get 3.5 amps. So that's just a really easy way to set the maximum current through the LED, because there's different currents for 100 watt LEDs. So let's take a look at the circuit board now. So here's the circuit board. I ordered it off of IT Studio, and they do an alright job. I don't see anything wrong with it. So there's the input side right there. There's the LM3409HV chip right there. It only comes in a very small pin pitch VSOP 10 package. And that is a pretty small pin pitch right there. Here's the main current shunt resistor. That's a 0.08 ohm resistor. I've seen an app note somewhere where you can get better current sensing if you do this nice little configuration right there with the current sense lines on a separate pad, and the resistor just solders all over it. Here's the main switching MOSFET right there, the recirculating diode and input capacitors. On the back, it's very plain. There's the 0.47 ohm resistors right there that you solder on if you want to change the current on it. And yeah, these are M3 drilled, so you can put M3 bolts through there. Just make it easy to mount it to stuff. I know M3 is pretty standard for 3D printing, for 3D printed parts. This is a close-up of a 100 watt LED that I purchased on eBay. You can see it's a chip-on-board topology. It uses 101 watt LEDs on there. Everything looked like it soldered pretty good. I had to touch up all of those these devices right here, the diode and the MOSFET. So here's the test setup. I got I can't see it, but tiny little power supply up there. Unfortunately, it only goes up to 700 milliamps, which is a big limitation of it. But we can test to see if it'll short out or not. I've got a 48 volt supply I'll plug it into next. So I jumpered the EN to V plus now, and it should light up. It's 10 volts, going up to 20 volts. And you can see a little bit starting. We're at about 25, and at 30 volts, it's lit up. So it looks like it's at least working under constant current of 700 milliamps. Well, I've hooked up that LED to the 48 volt supply. Through a 8 amp fuse, I couldn't find any smaller amperage. They're all like 2 amps or 3 amps, which maybe could work, but let's go with 8 amp. It should trip out after it's just dead short. And there's the driver right there, and the LED. And let's flip the switch and see what happens. Oh, that's bright. It's showing 0 volts. Here, let me reset. Wow, that's bright. Oh, the lead fell off. Okay. $37 volts. And dropping. It's about 35 volts. Let's check the frequency. Ooh. Oh shoot. Oh shit. Oh, that's hot. I think I don't know. It looks like the LED must have unglued itself from the heatsink. Well, I reset it up with I put heatsink compound on it now and a screw to hold it a little better. And I set this on a current mode. So hopefully the LED isn't burnt out. So let's turn it on again. And 1.6 amps. 2 amps. 2.5 amps. Ooh, that's bright. And that's about, yeah, that's right. Looks like the LED driver is working. Maybe it was just the lack of lots of heatsink compound and the poor mounting method. That must have just fried it. But that's a good result, and I don't think you can see it. Block there, see 2.5 amps right there. That's a good result right there. Lucky the LED didn't burn out either. Here it is with a small fan going over the heatsink. And there you go. See if that gets hot too. It's interesting how it steps through the current ranges. Like when it starts up, it's either under a current or over current, then it adjusts itself to fit the right amount of current, which is kind of interesting. See, it's 2.48. Okay, it didn't do it that time, but when you just start it up, it sometimes goes over, then it like backs down. Like the first time, I think it went up to like 2.75 amps, and then it bumped it down a little bit because it was over.